We are going to take some time playing around with the mean and median just to see what happens if we shift data values around and how that will impact the mean and the median. So again, the idea here is we are trying to see what happens to the mean and median if we add data values, if we shift them around. So to do this, we are going to play around in Desmos for a little while. So if we go over if it will load. All right. So over here, I have the data set from our previous video with the mean and median, and I also have put up a dot plot displaying the data. So we are going to experiment with what happens first if we simply change data values. So if, for example, we take, say, our 3, and we change that to a 1. Our median has stayed at 8, but our mean has now dropped from 7 to 6.8. If we change that back to a 3, now we're back to our 7 and 8. And now let's see what happens if we take that 3 and instead we change it into a 6. So if we took our data value 3 and we bumped it up to a 6, all of a sudden now our mean has gone up from 7 to 7.3. Our median is still at 8. Now if we change that to a 9, our median is still at 8. Our mean went up again. The median doesn't have to stay put depending on if we take a data value from below the median and put it above the median. But the median is much harder to shift simply by moving data values. The mean, on the other hand, shifts very easily because the mean is a numerical calculation. We added up a bunch of data values. If we change that 3 to a different number, it will change our total. So notice that when I lowered that number, we can do it with a different one. Let's take one of our 8s. Let's lower our 8 to a 1. So when we lower a number, it drops the mean. And in this case, it did drop the median a little. Right? If we raised that number, if we raise the 8 to a 10, we raise our mean. So if we lower a number, it lowers the mean. If we raise a number, it raises the mean. So going back to the 8 that we had previously. Now let's see what happens if we add data values. So our mean is at 7. Let me just draw a line through our 7. So our mean was at 7 to start with. Right? This was our mean. And our median was at 8. Right? So our mean is in blue, our median is in pink. And let's just see what happens as we add data values. If we add a 7, which was our mean stays at 7. So we added a number on that blue line. We're not going to upset the balance at all. On the other hand, if we add a number to the left of the blue line, let's go with a 4, our mean now has dropped. So we added a number to the left of our blue line. Our mean is now below 6.7. If we add a number to the right of our blue line, so let's try a 9, it raises our mean. So with the mean, if we're adding numbers, if we add a number right at the mean, it doesn't change the mean at all. But if we add a number above or below, it pulls the mean in that direction. All right. The median didn't shift much. So adding a number to one extreme or another doesn't change the median all that much. If we have a really large data set in particular, the median hardly changes at all when we add numbers. The mean, the more data values that we have, the less it changes. But it does still get shifted around if we add a higher or lower value than the mean. Last up, I wanted to talk about skew. So I'm going to go ahead and clear those two lines I drew. So in this data set, we have our peak on the right with a long tail to the left. And notice that our median falls more or less in our peak, that 8, but our mean falls to the left. So a skew pulls the mean in the direction of the skew. So if I created a new data set, let's call this list B. And in this data set, we will have 4, 5, 5, 6, 6, 6, 7, 7, 8. I forgot to put my square brackets. Let's do our square brackets. All right, so we have a data set. Let's go ahead and do the mean of that data set. And the median. My daughter is singing in the background for you. I'm not sure if you can hear it. And then again, let's do a dot plot. I'm going to turn off the other dot plot. Okay, so here we have symmetric with a central peak. Our mean and median were both precisely in the center at that 6. Okay. If, on the other hand, I shift that peak in one direction or another, let's see what happens. So let's say that we only had 1 5, 2 6s, and let's say that we had 3 7s and our 8. And so in this case, the peak has now been shifted to the right. Notice that our peak, our median is still very close to the somewhere in our peak. Our median or our mean now has been pulled to the left. If we had a lot more data, the median and a much longer tail, the median will appear more or less in the middle of wherever our huge clump of data is. The mean often gets pulled away from the clump in the direction of the tail. Similarly, if we had the peak to the left and the tail to the right, the mean will pull that skew to the right. So hence why we call this skewed right if the tail is on the right. All right, so that is sort of playing around with the mean and median. We're going to go back now to our notes and just do some summarizing. So what happens to the mean and median if we shift a value higher? The mean goes up no matter what. The median will most likely stay the same. It may also go up. So the median may not shift. What happens to the mean and median if we shift a value lower? If we shift a value lower, our overall sum is smaller now because one of the numbers we are adding is smaller. So the mean goes down. And again, the median might not shift. Talking about skewed left or right, how does that affect the mean and median? The median stays in the peak. Not necessarily at the exact highest value, but it stays in the hill, in the mountain. The mean gets pulled in the direction of the skew. So if we have skewed left, then the mean is pulled to the left of the median. If we have skewed right, the mean is pulled right of the median. Right? Again, just a reminder, skewed left, we have the long tail with a peak on the right. Skewed right, the peak is on the left, the long tail is on the right. The skew goes in the direction of the tail. I forgot to type the question earlier, but if we add data values, what happens? To the mean? Our goal is to keep the values balanced around the mean line. If we add a value above the mean goes up. If we add a value below the mean, the mean goes down. And if we add a value exactly at the mean stays put. So that's just some basic playing around with the mean and median. We will do more with this later.